The morning of January 3rd, 1945. A frozen field 3 kilometers southeast of Bastogne, Belgium. Staff Sergeant William McBride watched through his periscope as a King Tiger rotated its massive turret toward his M4A3E8 Sherman. The 68-ton German behemoth had appeared from behind a shattered farmhouse, its long 88mm gun already tracking targets. McBride's tank, nicknamed Easy Does It, weighed less than half that. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Its armor couldn't stop the Tiger's main gun at any range. In a static duel, his crew had perhaps 30 seconds to live, but McBride didn't try to run. He did something the German crew wasn't expecting. He accelerated directly toward them, traversing his turret as the tank moved. The Easy-8's horizontal Volute spring suspension absorbed the frozen ruts and shell craters with barely a shudder. The gyrostabilizer kept his 76mm gun relatively steady even at 25 miles per hour over broken ground. His gunner, Corporal James Hendricks, acquired the target. McBride's tank completed a full 360-degree rotation in 15 seconds. The German turret, dependent on engine speed and hydraulic pressure, needed at least 60 seconds for the same maneuver. By the time the King Tiger's gun bore aligned with Easy Does It's new position, Hendricks had fired 3 rounds. 2 struck the Tiger's right track and suspension. The third penetrated the thinner side armor. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The German crew bailed. The King Tiger, immobilized and smoking, would be abandoned within the hour. McBride's after-action report, preserved in the National Archives, noted with characteristic understatement, "Enemy heavy tank destroyed through superior maneuverability. New suspension system allowed engagement while moving at speed over difficult terrain." This engagement represented something unprecedented in armored warfare. An American medium tank had defeated one of Germany's most formidable weapons not through superior firepower or armor, but through a suspension system. The M4 Sherman, with horizontal Volute spring suspension, known to its crews as the Easy-8, could move and fight in conditions that left heavier German tanks struggling. It could traverse its turret 4 times faster than a Tiger. It could maintain accuracy while moving across terrain that would leave a Panther crew unable to return effective fire. Most importantly, it arrived in numbers that German industry, by late 1944, could no longer match. The story of how an improved suspension system became a tactical advantage begins not in combat, but in the testing grounds of Aberdeen, Maryland, in early 1944. American tank designers faced a problem that threatened to undermine the Sherman's effectiveness as the war entered its final phase. The original vertical Volute spring suspension, adequate when the Sherman weighed 28 tons, was failing under the increased combat weight of 32 tons, with heavier guns and additional armor. Track life shortened from 500 miles to barely 300. Ground pressure increased from 14.7 pounds per square inch to over 15 pounds per square inch on the 16-inch tracks. In muddy conditions, Shermans bogged down where German Panthers and Tigers could still maneuver. Lieutenant Colonel Harry Knox, who had experimented with horizontal Volute springs on the light tank T6 project in 1938, proposed adapting a British design. The Horstmann suspension used horizontally mounted coil springs to link paired road wheels. Knox's innovation replaced the coil springs with Volute springs, cone-shaped compression springs that slid over each other under load. When mounted horizontally, these springs created a suspension system where pressure on one wheel in a bogie was transmitted to the opposite wheel, maintaining tension across the entire track. The engineering was elegant. 2 road wheels per bogie, mounted on paired arms, connected by horizontally positioned Volute springs. When the front wheel encountered an obstacle, the spring compressed, transferring force to the rear wheel and maintaining track contact. The system doubled the number of road wheels from 12 to 16, while actually simplifying maintenance. Individual wheels could be replaced without removing the entire bogie assembly. Track tension remained consistent across varied terrain. Most significantly, the new system could accommodate tracks 23 inches wide, compared to the 16.6-inch tracks on earlier Shermans. Testing began in March 1944. The results exceeded expectations. Ground pressure dropped to 11.5 pounds per square inch, lower than the Panthers' 12.8 pounds per square inch, despite the Sherman's increased weight. Suspension travel increased, improving ride quality and cross-country speed. The shock absorbers mounted at the top of each bogie unit further smoothed the ride. Test drivers reported they could maintain 20 miles per hour over terrain that reduced VVSS Shermans to 12 miles per hour, but the real advantage emerged in the gunnery tests. The smoother ride meant gun laying remained more accurate during movement. The M4's existing gyrostabilizer, which attempted to keep the 76mm gun level in elevation, worked far more effectively when the tank wasn't pitching and rolling over rough ground. Gunners could engage targets while moving at speeds that would make accurate fire impossible from a Panther or Tiger. This wasn't a minor improvement. It fundamentally changed the tactical calculus of tank versus tank combat. The United States approved production in August 1944. Detroit Arsenal and Chrysler's Fisher Body Division began manufacturing M4A3E8 Shermans, the designation indicating an M4A3 with the 8th experimental variant, which became the HVSS suspension. By December 1944, the first Easy 8s arrived in Europe. They went immediately to units facing the German winter offensive in the Ardennes. The Battle of the Bulge, which began December 16, 1944, provided the first large-scale test of the HVSS Sherman against Germany's final armoured reserves. The German offensive concentrated heavy tanks, Panthers, Tigers, and even the rare King Tiger, in numbers not seen since Normandy. The weather conditions favoured the defenders. Snow, ice, and mud turned roads into quagmires and limited air support that had dominated earlier battles. American tank battalions, many still equipped with 75mm gun Shermans and older VVSS suspension, took devastating losses in the opening days. But the Easy 8s told a different story. The 4th Armoured Division, spearheading General Patton's relief of Bastogne, received its first M4A3E8 tanks in late December. The 37th Tank Battalion's after-action reports, compiled from daily summaries between December 23 and January 7, document 63 engagements with German armour. 41 resulted in confirmed enemy tank destroyers, 17 Panthers, 14 Panzer IVs, 7 Tigers, and 3 King Tigers. American losses: 9 M4A3E8 tanks knocked out, 6 of them repairable. The kill ratio, when compared to earlier Sherman variants against the same targets, represented a dramatic improvement. The tactical reports reveal why. Crews discovered they could use terrain that heavier German tanks avoided. The wide tracks and lower ground pressure allowed movement through snow that left Panthers and Tigers floundering. In one engagement near Chaumont on January 2, 1945, a platoon of 4 Easy 8s used a wooded ravine approach considered impassable by German intelligence. They emerged 300 metres from a lager of 5 Panthers preparing for a counterattack. The Panthers, with engines idled to conserve fuel, needed 90 seconds to bring their turrets to bear. The Shermans fired 17 rounds in that time, destroying 3 Panthers and forcing the other 2 to withdraw. Speed of turret traverse became a decisive factor. German tanks used hydraulic traverse systems dependent on engine RPM. At idle, a Panther needed 93 seconds for a full 360-degree rotation. At maximum engine speed, with the governor allowing 2500 RPM, this dropped to 18 seconds. The Tiger I, with its hydraulically assisted traverse, required 60 seconds at high engine speed, 360 seconds at low speed. The Tiger II, despite its improved traverse mechanism, still needed 19 seconds under optimal conditions. The Sherman's electric or electro-hydraulic traverse, powered by a dedicated motor, completed a full rotation in 15 seconds, regardless of engine speed. The Oil Gear Company's system, preferred for its precision and reliability, used a small electric motor driving a hydraulic pump. The gunner controlled traverse speed with a foot pedal, allowing everything from fine adjustments to rapid target acquisition. The system worked even if the main engine failed, drawing power from the tank's batteries. This technical advantage manifested in combat as a dramatic difference in engagement outcomes. Tank duels rarely occurred at the long ranges where German guns held an overwhelming advantage. Terrain, visibility, and tactical conditions typically forced engagements at ranges between 400 and 800 meters. At these distances, the Sherman's faster traverse meant the crew that fired first often fired twice before the enemy could respond. Combined with the HVSS suspension's ability to maintain accuracy while moving, this created situations where mobility trumped armor. Lieutenant Robert Early, commanding a platoon of M4A3E8 tanks in the 2nd Armored Division, described the tactical shift in his January 19, 45 combat report. "We don't try to slug it out with Panthers anymore. We move. The new suspension lets us fire on the move with decent accuracy. We can run circles around them, literally. Last week we engaged 4 Panthers in a town square in Houffalize. We came in from 3 directions, moving fast. They got one shot off before we disabled all 4. None of them could traverse fast enough to track us. Their crews bailed." The psychological impact on German tank crews became evident in prisoner interrogations conducted by the First Army's intelligence section in January and February 1945. Panther and Tiger commanders consistently reported that American tanks moved too quickly to engage effectively and demonstrated unexpected maneuverability in difficult terrain. Several German tank aces, veterans of the Eastern Front, admitted that the late-model Shermans presented tactical challenges they hadn't encountered with Soviet T-34 seconds. The T-34, while possessing good mobility, lacked the gun stabilization and rapid turret traverse that made the EZ-8 so difficult to engage. The material superiority that the EZ-8 represented went beyond its suspension. It arrived as part of a complete system that German industry could no longer match. Each M4A3E8 came with a Ford GAA-V8 gasoline engine, producing 500 horsepower, giving a power-to-weight ratio of 15.6 horsepower per ton. The engine, designed for automotive mass production, used parts interchangeable with civilian vehicles. Maintenance was simple enough that crews could perform most repairs in the field. The tank carried 71 rounds of 76mm ammunition, 600 rounds of 50 caliber ammunition for the turret-mounted machine gun, and 4,700 rounds of 30 caliber ammunition for the coaxial and bow machine guns. Compare this to the Panther. The Maybach HL 230P30 engine, a purpose-built tank engine, produced 700 horsepower but weighed considerably more and required specialized maintenance. The final drive, a persistent weak point, failed regularly under combat conditions. Track life averaged less than 150 kilometers. The complex interleaved road wheel system, while providing excellent weight distribution, became packed with mud and froze solid in winter conditions. Crews needed hours to replace a single damaged inner road wheel, a task requiring removal of multiple outer wheels. The King Tiger epitomized German tank philosophy pushed to its logical extreme. 68 tons of armor and firepower, nearly impervious to frontal attack, armed with a gun that could destroy any Allied tank at 2,000 meters. But that weight came with crippling disadvantages. Ground pressure of 1.02 kilograms per square centimeter meant poor mobility on anything but hard surfaces. Maximum speed of 38 kilometers per hour on roads dropped to 15 to 20 kilometers per hour cross-country. The Maybach HL 230P30 engine, already struggling to move the Panther's 45 tons, could barely motivate the Tiger II's bulk. Mechanical breakdowns exceeded combat losses. Fuel consumption of 270 litres per 100 kilometres meant operational range of 105 kilometres, less in combat conditions. Strategic mobility, the ability to move tanks where needed, became impossible when each King Tiger needed 4 railway flat cars for transport and specialised heavy tank transporters for road movement. The Americans produced 2,617 M4A3E8 Shermans before the war ended. Germany managed 489 King Tigers total, production constantly disrupted by Allied bombing and raw material shortages. In January 1945 alone, American factories delivered over 1,000 Sherman tanks of all variants. German production that month, 120 tanks of all types, including assault guns. The mathematics of attrition warfare had become insurmountable. The strategic implications of the HVSS suspension extended far beyond individual tank engagements. By early 1945, the American armored divisions had learned to exploit their tanks' superior mobility and reliability in ways that German commanders, constrained by fuel shortages and mechanical limitations, could not counter. The EZ-8 became the centerpiece of a combined arms doctrine that emphasized speed, flexibility, and overwhelming firepower concentrated at decisive points. The 6th Armored Division's operations in March 1945 demonstrated this evolution. Between March 1st and March 23rd, the division advanced 320 kilometers from the Saar River to the main river, destroying or capturing over 400 German armored vehicles. The division's EZ-8 battalions led these advances, using their superior cross-country mobility to bypass German strongpoints and strike deep into rear areas. Traditional tank doctrine emphasized set-piece battles between armored formations. The HVSS Shermans enabled a different approach: rapid penetration, exploitation of breakthrough, and encirclement of enemy forces before they could establish defensive positions. Tank commanders discovered that the EZ-8's mobility advantage grew more pronounced as German logistical systems collapsed. Panthers and Tigers, already maintenance-intensive, became nearly immobile as spare parts disappeared and fuel supplies dwindled. German tank recovery vehicles, never produced in adequate numbers, couldn't keep pace with the Allied advance. Disabled German tanks were abandoned in place. The Sherman, with its automotive-derived engine and modular suspension, could be maintained with basic tools and minimal spare parts. Damaged HVSS bogies could be replaced in under 2 hours. A thrown track, potentially catastrophic for a Panther with its interleaved wheels, took Sherman crews 30 minutes to repair. The psychological warfare aspect of this reliability disparity cannot be overstated. German tank crews knew that mechanical breakdown likely meant capture or death. Fuel shortages meant tanks were often towed into position, engines started only when combat was imminent. This defensive mentality, combined with the decreasing skill levels of replacement crews, created a self-reinforcing cycle of defeat. American tank crews, conversely, operated with the confidence that their vehicles would function, that reinforcements and supplies would arrive, and that tactical retreat was always possible thanks to their mobility advantage. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The experiences of Sergeant Robert Parks, a Sherman tank commander with the 4th Armored Division, illustrate the human dimension of this technological advantage. Parks kept a detailed journal throughout the war, excerpts of which were published in his 1948 memoir, Steel Thunder. His entry for March 15, 1945, describes an engagement near Mainz. We spotted 3 Panthers hull down on a ridge about 600 yards out. Standard doctrine said we should call for air support or artillery, but the new Shermans changed the rules. Lieutenant Matheson ordered a flanking maneuver. We came in from their right at full speed, maybe 25 miles per hour over rough ground. The suspension smoothed everything out. Tommy was able to fire on the move, something we couldn't have dreamed of in the old tanks. We hit the first Panther in the side before they even knew we'd moved. The second one tried to traverse, but we were already past his arc of fire. Third one got off a shot that went wide. We disabled all 3 in under 2 minutes. None of our tanks even got scratched. Parks continued. What struck me afterward was how the German crews looked when they came out. Not angry or defiant like the early war prisoners, just tired. Beaten. One of them, a kid who couldn't have been more than 18, said through the interpreter that his tank had been towed into position that morning, They had maybe 30 litres of fuel left. No spare parts. Their radio had been broken for a week. He asked if he could sit in our Sherman, said he wanted to see what it was like inside a tank that actually worked. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The technical specifications of the HVSS suspension reveal why it succeeded where earlier systems struggled. The horizontal orientation of the volute springs meant that compression forces distributed evenly across both wheels in each bogie. This eliminated the harsh ride characteristic of vertical volute systems, where each wheel acted somewhat independently. The shock absorbers, mounted at approximately 70 degrees from horizontal, damped oscillations that could throw off gun laying. The wider track, 23 inches compared to 16.6 inches, spread the tank's weight over a significantly larger contact area with the ground. Ground pressure calculations demonstrate the practical effect. The M4A3E8, at approximately 33 tons combat loaded, exerted 11.5 pounds per square inch of ground pressure. The Panther, at 45 tons with wider tracks, exerted 12.8 pounds per square inch. The Tiger I, with its broad tracks designed specifically to handle its weight, managed 10.6 pounds per square inch. But the Tiger II, rushed into production without adequate attention to mobility, suffered from 1.02 kilograms per square centimetre, equivalent to 14.5 pounds per square inch. These numbers translated directly into tactical mobility. Soil that would support a Sherman or Panther would bog down a King Tiger. British testing in March 1945 compared the HVSS Sherman against the Panther, Churchill, and Cromwell in flotation and traction trials. The tests used a muddy field near the School of Tank Technology at Chertsey, with soil conditions measured at 45% moisture content. The Sherman, with HVSS suspension and T66 tracks, navigated the field with minimal difficulty. The Panther, starting slowly due to poor traction, bogged down completely after 30 metres. Its gearbox jammed when the driver attempted to reverse. The Churchill, with its numerous small road wheels and long track contact area, completed the course, but only in first gear. The Cromwell, despite its lower weight, sank deeper than the Sherman in all configurations. The traction tests revealed another advantage. The Sherman, with extended end connectors or the wider HVSS tracks, demonstrated superior grip on slippery surfaces compared to all other tanks tested. The Panther, with its smooth steel tracks, showed very poor traction despite its greater weight and power. The report concluded, the M4A3E8 Sherman demonstrates superior cross-country mobility in soft ground conditions compared to all German tanks tested. The combination of low ground pressure and effective track design provides tactical advantages in terrain conditions common to Northern European operations. These technical advantages manifested in combat in ways that transcended simple tank versus tank encounters. The First Army's breakthrough from the Remagen bridgehead in March 1945 demonstrated how mobility and reliability created operational opportunities. The 9th Armoured Division, equipped primarily with HVSS Shermans, exploited the Rhine crossing by advancing 80 kilometers in 72 hours. German attempts to establish defensive lines failed because armoured spearheads arrived before the positions could be prepared. Counterattacks by German armour consistently encountered American tanks already in advantageous positions. Turrets traversed to cover likely approach routes, infantry support deployed, tank destroyers and artillery registered on kill zones. The speed of these advances owed much to the HVSS suspension's durability. Tank tracks and suspension components, subjected to enormous stresses during extended road marches, typically required frequent maintenance. The HVSS system's shock absorbers and reinforced bogie assemblies reduced maintenance intervals. Track life on HVSS-equipped Shermans averaged 1,500 kilometers, 3 times that of the earlier VVSS suspension and 10 times that of Panthers operating under combat conditions. This meant armoured columns could maintain operational tempo without lengthy maintenance halts. The logistical advantages of the Sherman's design philosophy became more apparent as the war entered its final weeks. Each American armored division had dedicated maintenance battalions with mobile repair facilities, extensive spare parts inventories, and trained mechanics. But the Sherman's design minimized the need for these resources. The Ford GAA engine used spark plugs, fuel filters, and oil filters identical to civilian applications. Volute springs, while purpose-built, were simple steel components that any machine shop could fabricate. The modular suspension meant damaged components could be swapped rather than repaired. Contrast this with German tanks, where specialized parts, lengthy repair procedures, and limited maintenance facilities meant that minor damage often resulted in permanent loss of the vehicle. German tank development in the final months of the war reflected the desperation of a nation losing its industrial capacity. The proposed E-Series tanks, intended to replace the Panther and Tiger, would have featured improved suspension systems and more reliable powertrains, but prototypes barely reached testing stages before the war ended. The infrastructure to produce sophisticated armored vehicles had been systematically destroyed by Allied bombing. The Henschel plant in Kassel, primary manufacturer of Tiger tanks, sustained so much damage that production became sporadic and inefficient. 300,000 man-hours to produce a single Tiger, compared to 10,000 for a Sherman, became insurmountable when factories operated at 20% capacity. The human cost of these technical decisions deserves examination. German tank crews, by early 1945, faced impossible tactical situations. Their tanks, when functioning, possessed superior firepower and armor, but they operated with crippling disadvantages: inadequate training due to fuel shortages, lack of air support, insufficient infantry cooperation, and mechanical unreliability that left tanks stranded. American crews, while always respectful of German heavy tanks' lethality, fought with the confidence that their training, combined arms, support, and equipment reliability gave them decisive advantages. Obersturmführer Hans Schmidt, a Panther commander captured in April 1945, provided revealing testimony to Allied interrogators. His statement, preserved in First Army intelligence records, captures the German perspective. In 1943, we felt invincible. Our tanks were superior to anything the Allies fielded. But by 45, everything had changed. It wasn't just that your tanks had improved, though they had. It was everything. We had no fuel. Spare parts didn't arrive. When something broke, we abandoned the tank. My crew started the war in Russia with a Panzer IV. Good tank, reliable. Then we got a Panther. Magnificent machine when it worked. It rarely worked. We spent more time repairing it than fighting in it. In March, we were issued a King Tiger. I thought we'd be unstoppable. We broke down twice in the first 50 kilometers. The final drive failed. We had no way to repair it, no recovery vehicle. We sat there waiting for fuel that never came. Your tanks came down the road 3 days later. We surrendered without firing a shot. Schmidt's testimony represents thousands of similar accounts. German armored forces in the West, by spring 1945, had ceased to function as a cohesive fighting force. Individual tanks and small groups fought with determination, inflicting casualties. But they could not influence the strategic outcome. The mathematical superiority of Allied production, combined with the tactical advantages conferred by reliable mobile tanks like the EZ-8, made German defeat inevitable. The final statistics tell the story numerically. Between January and May 1945, American armored forces destroyed or captured over 4,000 German armored vehicles in the Western Theater. American tank losses totaled approximately 800 vehicles, with roughly 50% repairable and returned to service. The kill ratio, heavily in favor of American forces, reflected not just numerical superiority, but tactical advantages stemming from superior mobility, faster turret traverse, better crew training, and overwhelming logistical support. The 7th Army's advance through southern Germany in April 1945 demonstrated the cumulative effect of these advantages. Armored columns advanced 30 to 50 kilometers per day, encountering sporadic resistance that was quickly overwhelmed. German armor, when encountered, was typically immobilized by mechanical failure or fuel exhaustion. Crews often abandoned their vehicles before contact. The few operational German tanks that engaged American forces found themselves outmaneuvered and destroyed by Shermans operating with combined arms support, air superiority, and artillery dominance. The engagement near Nuremberg on April 20, 1945, exemplifies the end state of German armoured resistance. Elements of the 14th Armoured Division encountered a defensive position anchored by 3 King Tigers and 5 Panthers. The German tanks occupied excellent hull-down positions commanding the approaches to the city. Traditional tactics would have called for a deliberate attack with extensive artillery preparation. Instead, the American commander used his EZ-8's mobility to identify a flanking route through heavily wooded terrain that German intelligence considered impassable for tanks. The HVSS suspension proved otherwise. The American tanks negotiated the forest approach, emerged on the German flank, and destroyed all 8 enemy tanks in 15 minutes. German return fire, hampered by the slow traverse of cold engines, and the inability to depress guns sufficiently for the close-range engagement, proved ineffective. Not a single American tank sustained damage. The German crews, veterans who had survived years of combat on the eastern and western fronts, surrendered after their tanks were disabled. One German tank commander, when asked why they hadn't repositioned to cover the wooded approach, replied simply, "We had no fuel. Our orders were to stay in position. Your tanks went where we thought tanks could not go." This engagement, replicated hundreds of times in the war's final weeks, demonstrated how technological advantages in suspension and mobility fundamentally altered tactical possibilities. The HVSS Sherman could execute maneuvers that heavier, more powerful German tanks could not counter. It could maintain fire accuracy while moving at speeds that made German return fire difficult. It could operate reliably under conditions that left German tanks immobilized. Most importantly, it arrived in numbers that German industry could no longer match. The EZ-8's success in the final months of World War II validated a design philosophy that prioritized reliability, producibility, and systematic improvement over the pursuit of extreme performance in individual characteristics. The Sherman was never the most heavily armored tank, nor did it mount the most powerful gun. But its combination of adequate firepower, sufficient armor, excellent mobility, and outstanding reliability made it the most effective tank in the conflict when judged by the metric that ultimately mattered: achieving strategic objectives. The legacy of the HVSS Sherman extended far beyond the German surrender on May 8, 1945. While other nations rushed to develop new tank designs incorporating the lessons of the war, the United States found that the EZ-8 remained entirely adequate for post-war requirements. The suspension system that had proven itself in the frozen Ardennes and muddy Rhine approaches would see service on battlefields that American planners had not anticipated in 1945. The outbreak of the Korean War on June 25, 1950, brought the M4A3E8 back into combat against an unexpected adversary. North Korean forces, equipped with Soviet-supplied T-3485 tanks, swept south with devastating effect against South Korean forces that lacked armored support. The United States responded by shipping approximately 200 EZ-8 Shermans to Korea in August 1950. These tanks, 5 years out of production and considered obsolescent by military planners, would prove remarkably effective against their more modern Soviet counterparts. The T-3485, introduced in 1944, mounted an 85mm gun in a 3-man turret. Soviet tankers considered it superior to earlier T-34 variants and more than a match for any Sherman. The specifications appeared to support this assessment. The T-3485's gun could penetrate 100mm of armor at 1,000 meters. Its sloped armor provided excellent protection. Its wide tracks and Christie suspension gave good mobility. On paper, the matchup favored the Soviet design. Combat told a different story. The first major tank engagement of the Korean War occurred near Daejeon on July 10, 1950, before American Shermans arrived. M24 Chaffee light tanks of the 24th Infantry Division encountered T-34 85 seconds and were destroyed without inflicting significant losses. But when Easy-8s arrived and met T-34 85 seconds in battle, the results reversed dramatically. Between August and November 1950, M4A3E8 units destroyed over 130 T-34 85 seconds, while losing only 14 Shermans to enemy tank fire. The HVSS suspension again proved decisive. Korean terrain, mountainous and frequently muddy, favored tanks with good cross-country mobility. The Easy-8's wide tracks and sophisticated suspension system allowed it to navigate terrain that bogged down T-34 85 seconds, despite their theoretically superior ground pressure. More importantly, the Sherman's superior optics, gun stabilization, and crew ergonomics gave American tankers consistent advantages in target acquisition and fire accuracy. Sergeant First Class Ernest Comer, commanding an Easy-8 with Company A, 72nd Tank Battalion, demonstrated these advantages during an engagement near Bastogne on August 31, 1950. His after-action report, which contributed to his receiving the Medal of Honor, describes encountering 7 T-34 85 seconds. We were moving up a valley when the T-34 seconds appeared on the ridgeline. They had the high ground, but we had speed, and the HVSS gave us stability on the rough terrain. I ordered driver to accelerate while gunner engaged. We hit the first T-34 while moving at probably 20 miles per hour over ground that should have made accurate fire impossible. The stabilizer and suspension worked like they did in Germany 5 years before. We destroyed 3 T-34 seconds in the opening exchange. The others couldn't depress their guns enough to hit us on the valley floor, and by the time they repositioned, we'd closed the range and flanked them. Comer's tank alone destroyed 5 T-34 85 seconds that day. Wounded and refusing evacuation, he continued commanding his platoon through 2 more engagements. His testimony to the tactical advantages conferred by the HVSS suspension echoed reports from 1945. Mobility, stability, and the ability to fire accurately while moving created decisive advantages, even against technically superior opponents. The Korean War also revealed that the Easy-8's reliability remained superior to more modern designs. The M26 Pershing heavy tank, introduced at the end of World War II and theoretically superior to the Sherman, proved mechanically troublesome in Korean conditions. Its complex transmission failed frequently. Its heavier weight limited mobility on primitive roads and bridges. Units equipped with Pershings often requested Shermans instead, valuing reliability and mobility over the Pershing's heavier armor and more powerful 90mm gun. The experiences of the 8th Army in Korea between 1950 and 1953 demonstrated that the fundamental design decisions embodied in the HVSS Sherman, prioritizing mechanical reliability and tactical mobility over extreme firepower and armor, remained valid even as tank technology advanced. The Easy-8 continued in frontline service until 1957, when M48 Patton tanks finally replaced them. Even then, many Shermans transferred to Allied nations and continued serving for decades more. Israel became the most significant post-war operator of HVSS Shermans. The Israeli Defense Forces received their first Shermans in 1948 and continued upgrading and operating them through the 1970s. Israeli engineers recognized that the HVSS suspension system's modularity and reliability made it ideal for continuous improvement. They retrofitted older Sherman hulls with HVSS suspension, creating hybrids that combined wartime chassis with post-war upgrades. The suspension system that had proven itself in Belgium and Korea demonstrated equal effectiveness in the Sinai Desert and Golan Heights. The most dramatic Israeli modifications produced the Sherman M50 and M51, mounting French 75mm and 105mm guns respectively. These upgunned Shermans, their firepower enhanced to engage modern Soviet tanks, retained the HVSS suspension that provided their tactical mobility. During the Six-Day War in 1967, Israeli M51 Shermans successfully engaged Egyptian T-54 and T-55 tanks, vehicles designed 20 years after the original Sherman. The encounters demonstrated that mobility, crew training, and tactical employment often mattered more than raw technical specifications. One engagement during the Six-Day War deserves particular attention. On June 5, 1967, a company of Israeli M51 Shermans encountered an Egyptian armoured battalion equipped with T-55 tanks in the northern Sinai. The T-55, with its 100mm gun and comprehensive armour protection, appeared overwhelmingly superior. The Israeli crews, however, used tactics that would have been familiar to American tankers in 1945. They used the Sherman's superior gun depression to take hull-down positions on reverse slopes. They exploited their optical advantages to acquire targets first. Most importantly, they used their mobility to maintain tactical initiative. The Israeli company destroyed 23 T-55 seconds while losing 2 Shermans. Post-battle analysis attributed Israeli success to crew training, tactical doctrine, and the fundamental mobility advantages that HVSS suspension provided. The 22-year-old suspension design, proven on frozen Belgian fields, demonstrated equal effectiveness in desert conditions against opponents that hadn't existed when it was designed. This adaptability, the ability to remain tactically relevant across different terrain, climates, and opponents, validated the engineering decisions made in 1944. The HVSS suspension system influenced post-war tank design in ways not immediately apparent. When American engineers designed the M46, M47, and M48 Patton tanks, they incorporated lessons learned from the Sherman's suspension development. The Patton series used torsion bar suspension, technically more sophisticated than Volute springs, but the design philosophy remained consistent: prioritize reliability, ease of maintenance, and tactical mobility. The Sherman's modular approach to suspension design, allowing complete bogie replacement in field conditions, influenced maintenance procedures across subsequent American tank designs. Soviet designers, analyzing captured HVSS Shermans, incorporated similar principles into their post-war tank development. The T-54, introduced in 1947, featured torsion bar suspension with design elements suggesting Soviet engineers had studied the Sherman's maintenance advantages. The ability to replace individual road wheels without complex disassembly, a key feature of the HVSS system, appeared in T-54 suspension design. Soviet military literature from the 1950s praised the Sherman's suspension for its battlefield maintenance characteristics, a remarkable admission given Cold War tensions. The technical success of the HVSS suspension derived from its elegant solution to competing requirements. Tank designers constantly balance contradictory demands: firepower versus weight, armor versus mobility, complexity versus reliability. The horizontal Volute spring suspension resolved several of these contradictions by improving mobility without adding significant weight or complexity. The system required no internal hull space, unlike torsion bars. It used simple compression springs rather than complex hydraulic systems. It provided excellent weight distribution and shock absorption while remaining maintainable with basic tools. The shock absorbers, a seemingly minor component, exemplified the attention to detail that made the HVSS system effective. Mounted at the top of each bogie, these dampers prevented oscillations that could throw off gun laying during movement. German tanks lacked comparable damping systems, one reason why their tanks couldn't maintain fire accuracy while moving. Soviet tanks, with their simple Christie suspension, also struggled with stability during movement. The Sherman's combination of HVSS suspension, shock absorbers, and gun stabilization created a synergistic effect where the whole exceeded the sum of its parts. The wider tracks, enabled by the HVSS system's ability to handle increased loads, provided benefits beyond reduced ground pressure. The 23-inch track contact area distributed impact forces more evenly than narrow tracks, reducing wear on suspension components. The track's design, with cast steel center guides running between paired bogie wheels, prevented track throwing even during violent maneuvers. Track life, a critical factor in sustained operations, increased dramatically. These seemingly mundane improvements had profound tactical implications. Tanks remained mobile longer, required less maintenance, and operated reliably under conditions that disabled less sophisticated designs. The production history of the HVSS suspension reveals American industrial capabilities at their peak. Detroit Arsenal, Fisher Body Division, and associated suppliers manufactured components for thousands of HVSS Sherman tanks while simultaneously producing other armored vehicles, trucks, and supporting the B-29 bomber program. The modular design allowed different manufacturers to produce bogie assemblies, road wheels, and tracks independently, with final assembly occurring at tank production facilities. This distributed production model, impossible for German industry even before Allied bombing intensified, exemplified the industrial advantages that ultimately decided the war. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The story of the M4 Sherman HVSS suspension is ultimately a story about how engineering decisions, made in testing facilities far from combat, created tactical advantages that soldiers exploited on battlefields across 3 continents and 2 wars. It demonstrates that tank effectiveness depends not solely on armor thickness or gun caliber, but on the complex interaction of mobility, reliability, crew ergonomics, and tactical doctrine. The Easy-8 succeeded because it made American tank crews more effective fighters, giving them tools that allowed skill and training to overcome opponents with theoretically superior equipment. The German tank commanders who surrendered to Sherman crews in the spring of 1945 learned a lesson that military historians would spend decades analyzing. Superior technical specifications do not guarantee battlefield success. The King Tiger, with its impenetrable frontal armor and devastating gun, represented the apex of German heavy tank design, but it couldn't reach the battlefield reliably. It couldn't maneuver effectively once there. Its crew couldn't respond quickly to threats. Its industrial production consumed resources that could have produced 5 medium tanks. Every technical advantage it possessed was negated by fundamental design flaws and industrial realities. The Sherman, derided by some historians as inadequate, proved adequate precisely where it mattered most, accomplishing strategic objectives. It crossed the Rhine when German tanks sat abandoned for lack of fuel. It maintained operational tempo when German mechanical complexity led to constant breakdowns. It fired accurately while moving when German tanks could only shoot effectively from static positions. Most importantly, it arrived in overwhelming numbers because its design prioritized producibility and reliability over extreme performance in individual characteristics. The HVSS suspension embodies this design philosophy. It wasn't revolutionary technology. British designers had used horizontal springs before. The principles of weight distribution and shock absorption were well understood. What made it effective was thoughtful application of engineering principles to solve specific tactical problems. Inadequate mobility in mud, rough ride, degrading gun accuracy, difficult maintenance under field conditions, insufficient track life. The solution created tactical advantages that American tank crews exploited to defeat opponents whose equipment, in isolation, appeared superior. The long post-war service life of HVSS-equipped Shermans, from Korean mountains to Israeli deserts, demonstrates that good engineering transcends its original context. The suspension designed for European conditions in 1944 worked equally well in Korean winters and Sinai summers. The modular design that facilitated wartime production allowed post-war upgrades and modifications. The reliability that gave American crews confidence in Germany provided the same assurance to Israeli tankers facing Soviet-equipped opponents 20 years later. The human dimension remains central to understanding the HVSS Sherman's success. Tank combat ultimately depends on crew skill, training, morale, and leadership. The Easy-8 gave its crews tools that amplified their effectiveness. The smooth ride reduced fatigue during long operations. The ability to fire accurately while moving gave crews tactical flexibility. The reliable mechanical performance allowed concentration on tactics rather than constant mechanical concerns. The fast turret traverse let gunners engage multiple targets rapidly. These advantages, individually modest, cumulatively transformed tactical possibilities. Staff Sergeant William McBride, whose engagement near Bastogne opened this narrative, survived the war and returned to the United States in October 1945. His tank, Easy Does It, completed the war without catastrophic mechanical failure despite months of combat operations. McBride's personal memoir, deposited with the National Archives in 1992, includes this reflection. People ask me about being in a Sherman. They've read that it was a death trap, inferior to German tanks. That wasn't my experience. My tank worked. Every day, it started, it moved, it fought. The new suspension we got in December '44 made a huge difference. We could go places and do things that earlier Shermans couldn't manage. I saw plenty of knocked-out Panthers and Tigers sitting by roads, not from combat damage but mechanical failure. I never saw that with our tanks. When we hit something, the mechanics fixed it, and we got back in the fight. The Germans couldn't do that by the end. They had better tanks on paper. We had better tanks in reality. McBride's testimony captures the essential truth about the HVSS Sherman. It succeeded because it functioned reliably under combat conditions that defeated more sophisticated designs. The suspension system that gave it superior tactical mobility represented American engineering philosophy at its most effective, identifying specific problems, developing practical solutions, and implementing them at scale through industrial mass production. The M4A3E8 Sherman with horizontal Volute spring suspension stands as a testament to the proposition that war is won not by perfect weapons, but by adequate weapons available in sufficient quantities, operated by well-trained crews, supported by overwhelming logistics, and employed according to sound tactical doctrine. The Easy 8 embodied all these factors. Its suspension system, a seemingly technical detail, created tactical advantages that crews exploited to overcome opponents whose equipment specifications suggested they should have dominated the battlefield. In the end, the Sherman with HVSS suspension didn't outgun King Tigers or out-armor Panthers. It outmaneuvered them. It outlasted them. It arrived in numbers they couldn't match. It worked when they broke down. It fired accurately when they couldn't traverse quickly enough to respond. These advantages, stemming from a suspension system designed to solve specific mobility problems, proved decisive in the grinding attritional warfare that characterized the final months of World War II in Europe. The German tank crews who encountered Easy 8s in those final months learned what American tankers had known since December 1944. Mobility, reliability, and rapid target engagement often matter more than armor thickness or gun caliber. The 68-ton King Tiger, theoretically invincible, couldn't rotate its turret fast enough to track a Sherman moving at speed across broken ground. It couldn't traverse terrain that the lighter, wider-tracked Sherman navigated easily. It couldn't maintain operational tempo when mechanical complexity demanded constant maintenance that German logistics could no longer provide. The story of the HVSS suspension is, ultimately, a story about how engineering excellence manifests not in extreme specifications, but in thoughtful solutions to practical problems. It's a story about how tactical advantages emerge from reliable execution of fundamentals rather than pursuit of technological supremacy. Most importantly, it's a story about how American industrial democracy, producing adequate equipment in overwhelming quantities, defeated German technological sophistication that couldn't be maintained, supplied, or produced in sufficient numbers. The Easy 8's turret traversed faster than a King Tiger's not because of revolutionary technology, but because American engineers prioritized this capability and designed reliable systems to achieve it. The suspension allowed accurate fire while moving not through complex innovations, but through careful integration of shock absorbers, wide tracks, and proven stabilization systems. The tank remained operational under conditions that disabled Panthers not because American steel was superior, but because American design philosophy prioritized reliability and maintainability. These lessons remain relevant. Military effectiveness depends less on individual weapon superiority than on systematic advantages in training, logistics, production, and tactical doctrine. The nation that fields adequate equipment reliably in overwhelming numbers, supported by comprehensive logistics, and operated by well-trained personnel, defeats the nation that produces sophisticated equipment it cannot maintain, supply, or use effectively. The HVSS Sherman proved this proposition on battlefields from Belgium to Korea to Israel. The suspension system that allowed a 33-ton medium tank to outmaneuver 68-ton heavy tanks represents more than mechanical engineering excellence. It represents the triumph of pragmatic design over technical perfectionism, of systematic advantages over individual superiority, of reliable adequacy over unreliable perfection. When Staff Sergeant McBride's Easy 8 engaged that King Tiger near Bastogne on January 3, 1945, the outcome was determined not by armor thickness or gun caliber, but by the ability to move, traverse, and fire effectively under combat conditions. The HVSS suspension provided that ability. American tank crews exploited it. German tank forces, hobbled by mechanical unreliability and tactical inflexibility, could not respond effectively. This is the legacy of the M4 Sherman with horizontal volute spring suspension, proof that wars are won not by wonder weapons, but by sound engineering, industrial excellence, and tactical doctrine that exploits systematic advantages. The Easy 8 wasn't perfect. It didn't need to be. It was adequate, reliable, and available in numbers that Germany could not match. That proved sufficient to help win the largest war in human history. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.